Hello class. Today we're going to talk about the research process. So how do we conduct research? What are the steps of conducting research? And then we're going to fill in we're going to do an overview today and then fill in all the specifics of every aspect of the research process later on in this class. So the first thing that I want to mention, what is the scientific method? So you guys have probably seen a flow chart that looks somewhat like this sometime in high school, middle school, and there's all these like 6 steps to do research, and it's very important that you know those steps, right? Well, the steps always vary in some way, so it's not incredibly important which specific steps we talk about, but let me give you the generalized version of this and talk about what's important. So the first thing is we need to have a research question, right? Well, why should we conduct research unless we have some question that we want to address? And after we have a question that we're interested in, then we conduct a literature review. We read all the previous studies on the topic, or we try to read all the previous studies on the topic to learn about the methodology that previous researchers have used. Maybe it's the case that they've already answered the question that we're interested in, and that would be embarrassing to do research. When it turns out that another study did the exact same thing as you did, you'd be surprised at how often this occurs. Then you might construct a hypothesis. Okay, you define your variables. Then you might conduct the study. Okay, you conduct the research study. I have an asterisk here because sometimes it's a research study, sometimes it might be a meta-analysis. A meta-analysis is a statistical technique where we take the results of many different studies and we combine them. Maybe this is a review paper. Maybe this is a case study where we're looking at one individual. After we've done conducting the study, we analyze the data. And an important point that's left off a lot of these flowcharts is the communication of the results of our experiment. It's very important that we communicate the results of whatever study it is that we've conducted. All right, we need to make sure that one of the key virtues of being a scientist is the publicness aspect, as I've stressed to you guys in class. But it's very important that we communicate our results because other people might try to conduct the same study that we have, and then they'd be wasting their time if they didn't know the results of our study. Replication is a very important aspect in psychology, which we'll talk about, where we might find one finding, but we need to make sure that it's consistent, that we conduct the study again and again and again and again to make sure that we find the same result, and that's the result wasn't just due to chance. It's the case that one person just due to chance finds a cool finding, and then everybody tries to replicate it and doesn't find that same effect. If they don't publish that, how are we ever going to know that that initial study was BS? So in this formulation, your flow chart in middle school or high school, this flow chart has specific steps and you have to go through them in a linear fashion. But conducting science is very rarely conducted in a linear fashion, right? Many points in time, we might be influenced and change our things. So for instance, it might be the case that later on we might change what our hypothesis was. Maybe we change what our research question was. Let me give you a couple of examples of how this flow chart can be turned up on its head. So maybe it's the case that when you were analyzing the results of your study, you come up with a new research question. I'm going to give you 2 examples of this, well, 2 famous examples. One of the founders of health psychology, a guy by the name of Hans Selye. Selye is S-E-L-Y-E. So Hans Selye was a new professor, and he was wanting to make a name for himself. And a biochemist across the hall from him that worked in the same university of him was able to look at ovaries and come up with some kind of extract from the ovaries. And he didn't know what it did, but he was able to come up with this, right? Some kind of hormone. But no one knew what this was. So Hans Selye wanted to make a name for himself, so he decided he was going to find out what this ovarian extract ended up doing. So what he decides to do is he gets a bunch of rats, and for half the rats, he injects them with this ovarian extract, this ovarian solution. And for the other half of the rats, he injects them with saline. Okay, saline is just salt water. This is to control for a placebo type effect. Maybe there's differences in the rats just to the fact that one has been injected with something and the other rats have not been injected in something. So he has an experimental group which has received this ovarian extract that we don't know exactly what it's going to do to them, and the other half have received salt water, a control solution. But as it turns out, Hans Silly is a really bad rat handler. All right, if you're a neuroscientist and working with non-human animals, you have to develop skills to interact with them, how to inject them with certain things, how to handle them, nurture them, all those sort of things. Hans Silly was really bad at this. So he would miss the injection site, he would drop the rats on occasion, he had to chase them around with a broom. And after, 2 weeks or so, after a period of time, Hans Silly looks at the rats to see what the ovarian extract has done to these rats. And he finds in the experimental group that they have a number of peptide ulcers. So they have ulcers in their digestive system. They have enlarged adrenal glands. So they have all of these physiological symptoms to them. And he's like, oh, cool, I know what this ovarian hormone does. Okay, I have figured it out. But then he looks at his control rats and he sees the same thing. They have a lot of peptide ulcers in their digestive system. They have very enlarged adrenal glands. Okay, adrenal glands is the glands that produce adrenaline, okay, or epinephrine, depends on what side of the Atlantic Sea you're on. Turns out that both of these rats had a bunch of peptide ulcers, and both of them had a lot of enlarged adrenal glands. Okay, why was this the case? Well, Hans Silly could have thrown up his hands and said, well, this research was a complete failure. I didn't figure out what this ovarian extract ended up doing. But it was weird that they ended up having these enlarged adrenal glands and ulcers. As it turns out, since Hans Silly was so bad at handling these rats, he was really stressing them out, okay? They were being chased around all day, they were being mishandled, and this elevated stress, which is a psychological phenomenon, was causing changes physiologically. This was the first time that a researcher had found that a psychological effect like stress, psychological phenomenon, had a physiological response in the body. Okay, enlarged adrenal glands, so elevated levels of adrenaline, and peptide ulcers. Okay, hugely important finding. So he conducted his research, and then he ended up changing course and formulated a new research question. And he started looking at the effects of stress on the body. Very important research. Another great example of this is from the wonderful psychologist B.F. Skinner. B.F. Skinner in his lab would create all these wonderful machines. He was very technologically gifted. Okay, he was very mechanically gifted. That's probably a better word to use. And he developed this Skinner box, is what we call it today, this operant chamber that when a rat would press a bar, it would receive a food pellet. And Skinner connected it to some machine that would let him know when the rat pressed the bar, at what period of time, and how many times it pressed the bar. So Skinner was doing some research, and he left the rats to their own devices and went home for the evening. And when he came back to his lab, he found out that one of the hoppers had jammed during the night, that instead of pressing the bar, the rat receives a pellet, it had to press the bar 3 times to receive the pellet, or it had to press the bar many times to receive the pellet. Skinner could have thought, oh no, this data is useless, okay? This rat ended up not receiving the same treatment as every other rat. Let's just eliminate that data. But that's not what Skinner did. Skinner was like, okay, well, let's see the results of learning from this rat. So then he puts all the rats on extinction, which means that when they press the bar, they no longer receive food. And he sees how long it takes for the behavior, the rat pressing the bar, to fully extinguish, for extinction to happen, that the rat stops pressing the bar. Now, for the rats that received continuous reinforcement, that every time they pressed the bar during that period of time, they received a wonderful food pellet, they stopped pressing the bar fairly quickly when they were put on their extinction trials. But the rats that received partial reinforcement, and it took them a lot of bar presses to receive the food pellet, their behavior persisted for a much longer period of time. It took a much longer period of time for that bar pressing behavior to extinguish, for extinction to occur. Skinner, in analyzing these results and this mechanical malfunction, developed a program of research on schedules of reinforcement, and he discovered the partial reinforcement effect. All right, if you're partially reinforced, you're reinforced every other time, every third time, that behavior is much less likely to extinguish, or it takes a much longer time for that behavior to extinguish than if you were to receive continuous reinforcement. For example, looking at people gambling. Okay, gambling, one of the reasons that it's very addictive and that people continue to gamble for such a long period of time is that you receive partial reinforcement. You know, if you buy a lottery ticket, most of the time you don't receive any money, but maybe every 20th time or so, you might get $5, you might get $20, you might get $50. So it's one of the reasons why gambling behavior is so prevalent and it's very hard to extinguish. All right, so analyzing the results of your study, even if your study messes up like that of Skinner, like that of Hans Selye, still might lead you to some cool research conclusions. All right, sometimes communicating your results leads you to new research questions. Many times when I present a poster, when I give a talk, someone will question my research and might say, well, could it be this other how about if we interpret your finding another way? And I go, wow, I never thought about that. And what I do is I take their ideas or their criticisms and I take it back into the laboratory and I try to change up my research. Okay, or I try to ask a new question, or I try to explain the research that I did in another way to account for some potential confounding variables. So communication is a very important thing. Your research gets a lot better. You might come up with new research questions and the process starts all over again. Okay, sometimes when we conduct a literature review, we come up with a new research question. Okay, maybe it's the case as well that when communicating our results, someone says, well, did you look at this paper from 1950s or 1954 or something? It's happened to me plenty of times where I will propose some research, I'll write up a paper, and then all of a sudden a reviewer of my paper will say something along the lines of, well, have you looked at this other literature that you might not be aware of? And I say, no, I didn't. And that might lead me to change how I write the introduction of my paper. This might change of the interpretation of my results. And I might be able to connect my experiment, my research study to some other disciplines within psychology. So the point that I'm trying to make here is that the scientific method, this flow chart, this research process is not linear. Maybe it's the case that in communicating with other people, you find another interpretation of your results. All right. Now, what you're typically told about the scientific method, what you're typically told about this research process is that before you conduct your study, you construct a hypothesis. All right. If the research turns out this way, this provides evidence for this theory. If it turns out this other way, it provides evidence for this other theory. But many times we reinterpret our research question after the study has been conducted. Sometimes this is a good thing, sometimes this is not a good thing, but we might come up with another explanation for our results, okay, after we've conducted our study. So let's construct a hypothesis before the study begins. This doesn't always occur, all right? We might reinterpret some of our research questions, okay? Sometimes when we're in the process of conducting our research study, we find that we haven't controlled for all potential variables. Maybe this leads us to ask some new research questions. So again, this scientific method, this research process isn't as simple as the flow chart in your middle school or high school would make it out to be. Okay, and last thing here, I believe that the literature review, when we conduct it, sometimes we find out that our research question is dumb and we need to revise it in some way. Sometimes in doing a literature review, we come up with a completely new research question. Okay, so let's go a little bit through each of these processes, each of these steps in the research process, and talk a little bit about them. So first of all, how do you find a good research question in psychology? And this is still something that, years into the discipline, that I'm still trying to come up with the best way to solve it. But there's many ways of coming up with a good research question. Okay, one, probably the best way, is to conduct a literature review. Read some papers that you're interested in, and you might come up with a topic that everybody has kind of skirted around, a gap in the knowledge, and this might lead you to conduct a new research study. Many times at the very end of a research paper, researchers make suggestions for future studies. Maybe it's the case that you conduct one of these future studies. All right. Research is always progressing. If you read the literature, you'll find out what topics are very important to researchers, how to conduct this research, and might spur you on to conduct a new research question. But it's always important to read the literature, right? I mentioned in the last lecture, and the lecture that we did in class, that Lumosity has argued that you can improve brain performance if you just do the same task over and over again. We do memory task over again, you improve memory. You do attention task over again, you improve attention. Does this work? No. And in fact, if Lumosity were to look at the literature, they would find that this is not the case. There's a wonderful series of experiments conducted by Thorndike and Woodsworth in 1901. And in this series of experiments, they train people on these very, very specific cognitive tasks. And what they find is that they don't transfer to even tasks that seem very similar to them. Thorndike and Woodsworth would give subjects a sheet of paper, and they had to mark all of the E's off that sheet of paper. And after a while, they got very quick at marking out all the E's, doing it again and again and again. Not very exciting task. But then they switched it to marking out all the I's. And now if you were, finding certain letters and marking them off, you would imagine that you'd get quicker at this, and it would transfer, and you'd be better at marking out a different letter, like an I. No, doesn't happen. Okay? When we train on a particular cognitive skill, we get good at that specific skill. It doesn't really generalize to other things. If Lumosity were to have read that paper, they would have maybe not started their company. Or maybe they would have, because they're greedy and they want to make money. But literature review is always a good way of first starting out to find a research question. Previous research is a good way of finding out new research ideas. So one experiment that my graduate professor conducted, he was looking at the effects of motivation on memory performance. All right. Is it the case that people that are more motivated do better on a memory task? All right. And can motivation explain why some people are good at memory tasks and why other people are bad at memory tasks? So if we were to motivate everybody, maybe everybody's good at memory. That might be a criticism. Okay. So what he ended up doing, and what his students ended up doing, was that they gave subjects on certain memory trials money for them to succeed. And on other trials, they did not receive any money for doing well at the task. So some trials you were paid if you did well, some other trials you were not paid if you did well. So this was the initial research study. And to measure motivation, the researchers looked at pupillometry, how big your pupils are. So the size of your pupils is an indirect measure of how much attention you're paying to something, okay? How much attention you're paying to something, how big your pupils are. And if you're paying more attention, you see that your pupils dilate a little bit. And what my graduate professor found was that people, before they even came to the experiment, okay, or as soon as they came into the experiment, before the task was explained to them, people that had higher memory capabilities had bigger pupils or bigger baseline pupil size than individuals that did poor on memory tasks. All right, and this was a weird finding. So a good colleague and I decided to look at this research and conduct our own research studies looking at what pupil size is correlated with. And what we ended up finding is that pupil size, baseline pupil size, so your pupil size day to day, is correlated with a wide variety of things. It's correlated with how good you are at attention tasks. It's related to how good you are at short-term memory tasks. We specifically call these memory tasks working memory tasks, but you'll talk more about that when you have cognitive psychology. So interesting relationship. Why do we think that this exists? Well, pupil size also is an indirect measure of how much norepinephrine is in your brain, how much norepinephrine is in your brain. And so maybe this elevated level of norepinephrine explains why people that have larger pupil sizes, larger baseline pupil size, are more intelligent, do better at memory tasks, do better at attention tasks. But that research is still ongoing. Very interesting finding there. Maybe societal issues. So what are some important societal issues? Maybe this might spurn some research questions. Okay, a great example of this is some research by Lawtonay and Darley on the bystander effect. So in the 1950s or 1960s, around that period of time, this woman, Kitty Genovese, was brutally murdered outside of an apartment complex. And the interesting thing about this was that, someone came, they stabbed her, she was on the ground dying. 30 minutes later, that person came back again and finished the job. So this was horrible. But in the apartment building across where she was murdered, there were tons of people that saw it. Okay, tons of people that saw this murder taking place, and not a single one of them called the cops. If they had called the cops during this period of time where she was bleeding, she could have been rescued. So some newspapers ran ads like New York City. This took place in New York City, by the way. That New York City was a cold and uncaring place, and that people were becoming more and more emotionless. That city life led people to be cold and unempathetic. But Darley and Lawtonay, didn't buy this, and so they conducted some research of their own, and they found out that when responsibility is diffused among many people, people are less likely to help. If you're the only person that sees something, if responsibility is solely on you, well, then you're more likely to help somebody out. So some of the examples of some studies that they've conducted, you sit in a little booth, and it's supposed to be a memory task, or they tell you some lie that the task is something different. And you either believe that you're on the phone with an experimenter, and that's it, or you're on the phone with many other subjects and the experimenter. And then the experimenter, who's a Confederate, fakes a heart issue. If you are there and you believe that there's many other people around you in these booths, you're not likely to help out. You think to yourself, well, maybe it's maybe somebody else that's going to help out, but somebody else surely will go and check on this person. If you think that you're the only person there and you're the only person that hears that this person's struggling and having heart problems, then you're more likely to help out. This is the bystander effect. All right. This research was conducted because of this story of Kitty Genovese. Some other examples here. During World War I, all right, many soldiers that were enlisted had problems following directions. All right, and it's not very useful to have a soldier that's not going to listen to you, that doesn't understand the English language. So maybe it's a good thing to test for intelligence, but how do you come up with a way to test for intelligence to make sure that those people that are being drafted, those people that are being enlisted, that they have enough intelligence to be a successful soldier? Well, Robert Yerkes, affectionately known as Bob Yerkes, was put in charge of a task force to help develop tests for the American military to select for individuals that had a decent amount of intelligence that they would be able to succeed and be a successful soldier. So again, a societal need led to some important research. And in fact, this was the very first group test of intelligence. This need to have intellectually competent soldiers led to some of the most important research in intelligence testing. All right. Today, a lot of our troops are over in foreign countries, maybe something like Afghanistan, maybe like something like Iraq. It's very important for them to have a translator there that's able to effectively communicate. So how do you select for someone to be a translator? Some of the research that I did in graduate school, we helped develop tests, very similar in some ways to Bob Yerkes and the research done on World War I soldiers to select for translators for the military. Who would make a good translator? Because it costs a lot of money to train somebody to be a translator. And if it turns out that you don't have the cognitive capacity, you're just not that good at learning the language, the military ends up wasting a lot of money putting you through this training when you just can't cut the mustard. So societal issues can lead to some important research questions. All right, another way to formulate a research question is just be a common sense. Maybe it's the case that some common sense explanation for something turns out to be false, and you want to test and see if it's actually true. There's this fun song from the 1970s by Mickey Gilley, "Don't the Girls All Get Prettier at Closing Time?" The idea behind this song was that at the beginning of an evening at a bar, people look normal, they don't look that attractive, but after enough alcohol, okay, maybe after enough desperation, people start looking more attractive. One of my graduate professors was a graduate student, and his professor, a Pennebaker, decided to test this hypothesis out. So my professor and all of his colleagues went to bars and had people rate the attractiveness of people around them. And what they found is that indeed the girls do get prettier at closing time. Okay, as desperation sets in that you're not going to go home with somebody else, the options that are still there start to become a whole lot more appealing. Okay, and that's what this research paper ended up finding out. I do love the title of this research paper. "Don't the Girls Get Prettier at Closing Time? A Country and Western Application to Psychology." Wonderful, wonderful title of a paper. Okay. Let's stop this video right here, and we'll continue this lecture in the next video. Thank you guys, and see you in the next video.